It'll be similar to last week, where there will be half an hour of new material at the beginning, then do nothing for 15 minutes and make the quiz available at 2:15, and then you have until the end of the class to hand it in. Today, again, will be like last week, which we'll go over the homework for section 2.5. Probably only do one of the ones from 2.7 because it's not going to be on the quiz. Then we'll look at the review, which I put on Blackboard if you want to look at it from there, or I'll share it here. Give you the 20-30 minutes to try it on your own. We'll come back and do it, and then however much time we have left, we'll continue into section 2.9. Little thing, if you look, the grades are up now on Blackboard for quiz 1. Two things. At some point, someone will tell me. You should have, in some ways, 2 columns for quiz 1, and that's because not everyone submitted it through Blackboard. So the first one, I think, is the one that really matters. So if you have 2 and one of them, for example, has a 0 and the other has some grade, ignore the 0. Again, if you didn't submit it through Blackboard, if you want to see comments and so on, if you email me, I will email you my corrected version. And again, if you have questions about the grading, so it should be on, if you go into your grade book, it should be there. Huh, really? Interesting. So I'll have to go in, because obviously I see it differently than, oh, there we go. So people explain it. Thank you, everybody. Because I don't see the same thing you do, so I'm not sure. So actually, I might as well ask. He said that he made, if you got any points off, he made comments. Can you actually see your quiz if you submitted through Blackboard? Has anyone tried looking at it? Okay. All right, so I'll have to see how it works. Blackboard's a bit picky, so I'll have to see if I have to do anything to make it available to everybody. Certainly, I can get to the actual quiz. So if you do think too much was taken off, even if you don't know what was taken off, if you email me, I can look at your quiz and see what it is. Oh, and then thank you. So it's in Tools. It says. So see if you can see it. Obviously, if you got a 30 out of 30, then you probably didn't comment because you didn't get anything off. Okay, so let's look at homework, and we are in .5. And let me start with, as usual, a really basic one. Remind you of what we're doing in the section. So in one, first thing is, many of these, they're asking you to graph the level sets and then graph some of the gradients. You don't have to worry about that for quizzes or tests. It's really just to show you what we said yesterday, which is that the gradient is perpendicular to the level sets, but you don't really need to do that. Although I will look at one particular one because there's one little side thing that I didn't talk about yesterday. So here, what we're just doing is find the directional derivative of f in the direction of v. That's actually part A. Actually, I might be thinking of 2.7, but that's okay. I might be thinking of 2.7 where they're asking you to graph it. So what's the directional derivative of f in the direction of v? So first little step I have to do is get the magnitude of v, because I need to make v into a unit vector. And so that's square root of 26. And then what do I do? Right, so then take the dot product with the gradient. So that's basic thing from the section, which is directional derivative. I'm trying to fit it onto this page. In which direction does the function increase as rapidly as possible? And what is the rate of change in that direction? So in some ways, let's start with the rate of change, because that goes into the direction. So what is the rate of change in the direction that we're increasing most rapidly? Right, so the magnitude of the gradient. And the direction is in the direction of the gradient. So 1 over 5 multiplied by the gradient, so now it's a unit vector. And that first number there inside the vector is, of course, the -3. Okay, so they're the basic ones. And what do I do if instead I want the direction that f decreases as rapidly as possible? Just put a negative, so the rate would be -5, and the direction would be the -1/5 of the -3/4, or 1/5 +3 -4. And then C asks, so I'll have to go to the next page. So any questions on this before I erase? In which direction is the rate of change equal to 0? Oh, 3. Yeah, so 3. So perpendicular to the gradient. Which means I need the dot product, and the gradient, as the reminder, was the 3 -4. Except I said it backwards. So there are two possible answers here. What is one of them? Right. So for 2, it's easy, just switch the order and change one of the signs. And of course, to make it a direction, you're going to have to divide through by the 5. But if you forget, pretty much just you're looking for an x and y, so that -3x plus 4y is equal to 0. So put in any number for x or y and solve for the other. And there are two ones because this is going one way, and then we go the opposite direction where we could make it 1/5, -4, -3. Okay, so let me do another. So we look at 12. Look at the wrong place. So 12 says, suppose we have the function x squared plus y cubed plus c to the 5th. So just one more variable. And we're looking in the direction of 1, 1, 1, and we're at the point -1, 1, 1, -1. And again, let's find the directional derivative. So they're pretty much the same as the last one, just they make you actually do, and obviously this is a simple one. Get the gradient. So what is the gradient? You're probably just easy to give it to me as opposed to tell me in general. So you can see I was getting ahead of myself. So there's the gradient at the point. And then from here, it's pretty much the same as the last one. I get the length of v because I need to make it a unit vector. And take the dot product. So pretty much the same thing, just make you actually take the derivative. And of course, this part, since you're doing these partial derivatives, I probably wouldn't have just a standalone where I ask you to get the derivative. So I might make the function slightly more complicated, see if you remember the chain rule and the product rule or something like that. And then 26 continues 12, where it says, pretty much, again, the follow-up, the same as the last one. In which direction does it increase most rapidly, and what's the rate in that direction? In which direction does it decrease most rapidly, and what's the direction? In which direction is the rate of change 0? It's pretty much the same thing as the last one, except now it's three-dimensional. But so go through the pieces, all of them are fairly quick. So what is the largest possible rate of change? And again, same as the last one, it's just the length of the gradient, which and as always, checking to make sure that the numbers are okay, is the rate. And the direction is, again, just that. So nothing new. As you told me for the last one, all I have to do to get the direction and the rate for decrease by -1. Here I'll just distribute it. So here they ask for something more general than I would on a quiz or test, which is they're saying, give the two properties I need so that the direction will be in the direction of where the rate of change is 0. And so what are the two things we need to get that direction? What are the two things true about make it x, y, z? So that's a direction, and that the rate of change in that direction is 0. Yes. So yeah, I distribute the negative, but you don't have to for the decrease. So two things I need so that the rate of change is 0 are what? That's 1. So that for the quiz, that would be good enough, which is we need that the dot of the x, y, z and the gradient is 0. And because it's direction, we need that, what else? So I'll use your 0, -5, 3, but right. So we need a unit vector. So in the answers, they probably say something like, and this is even, so it's probably not there, that we need -2x plus 3y plus 5z is equal to 0, and we need squared plus y squared plus z squared is equal to 1. But for a quiz, you can simplify it, and I'm not sure why I changed the signs, but that's okay, by just making one of them 0, and then as we did the last one, flip them and change one of the signs, and then just make it a unit vector. By dividing through by the length. So pretty much these two are the two types of problems. As I said, about the only thing for the quiz is I might make the function a bit more complicated, check to see if you're okay with taking the derivatives. So those ones I want to look at from 2.5. The other ones that you want to look at? Oh, 38. This one is 38. And this one's in 34 because notice. Yeah, as soon as I notice it. So number 7. Okay. So we want to get the rate of change of f in the direction of v if we're at the point 2,1. So I'm not sure why it bothers with this, but why? So this part's no different. shuffling numbers, but why not? Oh, so yeah, so as usual, it's changing it doesn't like my 3's when I write them, so it tries to smooth them out. Root 3 and root 13. So it's the same as the last couple. It's just that now the derivative, as I said I might give you for the quiz, is slightly more complicated. So we need for the gradient, we need the derivative with respect to x and the derivative with respect to y. And I'm trying to think if there's an easier way. We can use the quotient rule, or we can try to rewrite it, but I'm not sure that's going to help much. So just quotient rule. So reminder. What is the quotient rule? Derivative of f over g is luckily most of these are pretty simple derivatives, so it's even though it's quotient rule, it's not too bad. So it's this thing. I'd like that to make it obvious that there's no derivative there. Of course, it's slightly more complicated looking here because we have derivatives with respect to x and y's and so on, so the prime doesn't really make sense. But so therefore, the derivative with respect to x is the derivative of the numerator with respect to x, which is 1 times the denominator minus leave the numerator alone times the derivative of the denominator with the denominator squared. That's supposed to be a minus inside there. And pretty similar for the derivative with respect to y. Still 1. Except now the derivative of that will be negative 1. We could try to simplify, but probably not worth it just because we're going to be plugging in numbers, so I'll just plug in numbers. So that is minus 2 and 4. Wasn't liking my negative 2. So 1 plus 3, yeah. Okay. And then once we have that, now it's just, as usual, the dot product. Although whatever that is. And you could leave it like that. But, or you can get it as a decimal, whichever you'd rather. Okay, it doesn't really simplify very nicely, so I'll just leave it like that. So any questions on this? In one sense, it's pretty much like the last one we did, and the other sense, it's a pain because the derivative is a bit of a pain. Any others that you want to look at? 33. So it says, suppose the XY plane has an electrical charge in coulombs given by this, where X and Y are in meters. Suppose we are at 1, 1. If the particle moves in the direction in which the charge increases most rapidly, in which direction does it move? Oh, and then C is a little bit different. So A is similar, so we need to get the gradient. And again, similar in idea to the last level, again, it's slightly more complicated because when we take the derivative with respect to x, first term certainly fine, but for the second term, I need product rule. Oh, yes. Very good. It's easier than I thought. Yes, it's pi y. So I don't need the product rule. Simplifies things. I guess I wanted it to be product rule, but it's easier. And do my usual backwards way. So leave the x squared alone, or the sine as the cosine, and then times the derivative of the pi y. And if we put in 1, 1, we get, so sine of pi is 0. So we get 1. And cosine of pi is -1. So we get minus pi. So there's the gradient. Not a great number, so if we're looking for the direction, we need the length of that. Which doesn't really simplify much. So 2 minus 2 pi plus pi squared. So I'll just leave it like that. B then says if the particle is moving in that direction with a speed of 1 meters per second, at what rate is the charge changing in, and I should have put in the coulombs per meter here. And what is the rate of change, again, if we start at 1, 1? And so in some ways, what that needs is to remember what this is saying. This says, for each meter I move, this is how much the charge changes in coulombs. Oh, actually, so that's the direction, the rate. The rate, this is equal to the rate. So it's also in coulombs per meter. So if I'm moving at 1 meter per second, then how much does the charge change in 1 second? And in some ways, this is not a nice one to ask the question. And since we're going to multiply the coulombs per meter by the meters per second, we're going to get the coulombs per second. And since we're multiplying by 1, it stays the same. if you're moving at 7 meters a second, what would I do to get that? Yeah, just multiply by 7. So in some ways, this is just remembering that this is sort of a little chain rule, which is we have a function inside of a function, and so we multiply the one times the other, f prime times g prime. Any others? Right. So as I said, 2.7 is not on the quiz, but to keep it in mind, let me look at 1, and it lets me also fill in one little thing I didn't talk about, which the reason I forgot is you don't really have to worry about it too much, but it is sometimes in the background. And this is what I was thinking of when I said the beginning of 2.5. Sorry, 2.7. So homework from 2.7. Number 1 says, if we have the function xy, then find, so really it says graph the level sets and then graph the gradient at 1, 2. But here I'm just going to say find the tangent line so don't worry about the graphing. No, so you won't have to graph. As I said, although I was thinking of the wrong section, what they're having you look at is by graphing the gradients and the level curves, you will see that, yes, they do appear to be perpendicular. So hopefully that means the fact that I didn't prove it isn't that big a deal, because you can kind of see that they are perpendicular. So like most of this chapter, your first step is to get the gradient. And then get the gradient at the point. And then what is the equation of the tangent line? And equal to 0, not equal to a number. So in some ways this is why I'm leaving this off, because it confuses between this one and 2.3, I think. We have the two different ways of getting tangent planes and lines. So usually a few students find it confusing, so let me just leave off the second way of doing things. Because the other way is, if I want to get the tangent plane at the point 1, 2, then I would get the gradient, I would get the value of the function at 1, 2, and then do z is equal to that value plus what I have here. So we have these two two things that are similar that you do in a slightly different way. But the reason I want to do this one in particular, so this is what we're doing in this section, and the only reason this is a tangent line is because we have, once we set the xy number, which is again, remember what we do for a level set, we have a two-dimensional thing, and therefore the tangent set will be one-dimensional, which is a tangent line. If I made that xy z, then that would be a three-dimensional object, and the tangent set would then be a tangent plane. But otherwise, the way you get them is exactly the same. It's just that you have one more variable. But as I said, the reason I want to do this is let me ask a second question. Let me do a couple of them. So let's do through 1, 0, and then I'm going to do 0, 0. So 1, 0 would give us then the gradient at 1, 0 is 0, 1. And then what is the tangent line there? Yes. So I'm going to write it like I did before. It's going to be the 0 plus 1 times y minus 0. But of course, yes, it becomes y equals 0. Same question. What is the tangent line through the point 0, 0? And right, so the idea is we get this really weird things because we get the gradient at 0, 0 is 0, 0. And that would give us this silly thing, 0 is equal to 0, which isn't a line. There are no variables, so it's really nothing. That's always true. So let me look at what's happening here. So this, as I said, I sort of will write do the drawing. So if I start doing level sets, then for example, what does the level set at 1 look like? Actually, that's not something you can actually easily answer, but you're getting y equals 1 over x, which looks like that. If I made it -1, it would instead be in the second and fourth quadrant. So what if I try xy equals 0? And this I'm not going to be able to draw very nicely, but what would be the level set for that? What are the solutions? Right. So it's this thing here. Trying to make it obvious to those who do things. So this is the level set at 0. So you can see if I'm anywhere like here, it's pretty obvious that, well, the tangent line is just y equals 0 because it's a line. But why is there a problem at 0, 0? Well, because there are two lines going through there, right? So which is it? And the idea is, well, it's a problem. So 0, 0 is a problem point. So it's given a name. It's called a singular point. And so at 0, 0, there isn't a tangent line because they're in some ways two. Similar, if you remember from Calc 1, if you looked at the absolute value, the derivative isn't defined at 0 because the slope abruptly changes. It changes from -1 to 1. And so if I look one way, the slope is 1. If I look the other way, it's -1. And so it is also a place where the derivative doesn't exist. So this happens if it is a singular point, then the gradient is lots of zeros. So if we get a gradient with which lots of zeros, a lot of the stuff falls apart because something weird might be happening at that point. Doesn't have to, but it could be. Right. So that's why I just wanted to fill that in. As I said, you're not going to see it much. Usually in the background, we'll try to make it so it isn't that, so that we can do problems. But in the background, it could come up, not for us, but in other places. Okay. So otherwise, like last week, so now I'm going to stop recording because now I'm going to give you the 20-30 minutes. You're going to work on the quiz review. I'm going to share it. So let me actually stop recording because